For the method of initial rates, we're starting with these volumes. And the concentrations are 0.1 and 0.1 for the two reactants. So the question is then, how do we change this reaction to determine the effect of concentration on the rates? So students by this time know that, well, we want to double the concentration and see what the effect on the rate is. And so, as I mentioned, we're measuring milliliters per minute. And so that's data for the first minute. So students know they want to double one of the concentrations. So they'll do this. So they'll leave the hydrogen peroxide concentration constant, so they think, but they'll double the concentration of potassium iodide. The problem here is that because the total volume is not constant, then doubling one volume doesn't really double the concentration. It sort of does. This is what students will do. What we really want them to do is make the total volume the same. So in trial 1, 75 milliliters of potassium iodide is in the total of 300. So in trial 2, when they make the potassium iodide 150 and leave the hydrogen peroxide at 75, we want the water then to be 75, so that the total is then actually 300 again. And now this is twice as much, this is the same, and we don't really care about the water. And then we should get approximately a doubling. It turns out that the rate is dependent on the concentration of potassium iodide to the first power. So we say the reaction is first order in potassium iodide. They will do the same thing, 150 of 150 of hydrogen peroxide with 75 of potassium iodide and still 75 of water, and they should find out also that it is first order with respect to hydrogen peroxide. So doubling the hydrogen peroxide concentration while keeping the potassium iodide concentration constant should also double the rate, which we're counting by the milliliters per minute. And again, they're measuring 4 1-minute intervals and getting the average. And some students always want to say, well, why don't we just add it for 5 minutes and divide by 5? Because the volume that they're going to capture is probably larger than 100 milliliters in most of these cases. And so we want the procedure to be the same every trial. We'll just collect it minute by minute. So the second trial looks like that. The third trial, just the reverse. And we usually get fairly good results. There's a lot of mess in there, but I tell my students it's either going to be zero order, first order, or second order, so whichever is closest. And so what they're asked to do in the analysis is divide their milliliters per minute for each manipulated trial by the milliliters per minute for the first trial. The first trial is our standard or control, if you want to use that term. The people across from them at the table have to do their original 75, 75, 150 trial as well, and then they have to come up with 2 other manipulations. And I usually tell them, once you've done doubling and doubling, probably tripling. So 225, 75, 0, or 75, 225, 0, and somewhere around 3 times the amount of product per minute. So again, if we triple the concentration of one reactant, leaving the other concentration constant, and we get a tripling of the rate, 3 times as much volume per minute, it's a first order reaction. And it turns out that both potassium iodide and hydrogen peroxide are first order reactants. And we'll talk about the rate law in just a minute.